All right, we're back. This is 4.1a, coterminal angles. There are 3 review questions. They should deal with what we just covered in the last set of notes. So go ahead and do those, and I'll be back in just a moment. Pause the video. You probably didn't understand number 2 because obviously we are talking about that right now. And I should have gone ahead and just cut that out. Didn't realize that was in there. Sorry. Change 5 pi over 6 to degrees. Well, that would be 150 degrees. And then how many degrees are in exactly 1 radian? We talked about that yesterday. And realistically, it's just 180 degrees, and we're dividing that by pi, which is basically 57.3 degrees, roughly. So those would be your 2 answers. Today we're going to talk about coterminal angles. These are angles with the same terminal side. They land in the same position. This first part, it's saying find a positive and negative angle less than 1 revolution that is coterminal with the given angle. When we say less than 1 revolution, I wrote this right up here and I'm going to finish it. Less than 1 revolution means your answer should fall between 0 and 2 pi or 0 and 360 degrees, depending on which one they actually do. It should be positive, obviously, between those 2 values. And it depends. If they're in degrees, state your answer in degrees. If they are in radians, state your answer in radians. So down here it's saying find a positive and a negative angle less than 1 revolution that is coterminal with the given angle. 400 degrees. When we think about 400 degrees, it's a little more than 360. What we want to do is just subtract from there. So if I have 400 degrees, I'm going to subtract 360 degrees. I want to subtract 1 circle, so that puts me into the range between 0 and 360. In this case, that would be 40 degrees. So that would be 1 positive angle that is going to be less than 1 revolution. Now, it's also asking me for a negative angle. And if I'm looking for the negative angle, it also has to be within 1 revolution negative. So if I know this one is going to give me the positive answer I'm looking for, then I could just keep going. I could subtract from 40. I could take away another 360 degrees, and that would give me the negative coterminal angle that I'm looking for. Remember, coterminal angles, I'll just do it over here. If you've got an angle measure, and let's say we start, here's my initial side, and let's say that the angle that we're talking about is this. So the first one was right here, and let's say this was 400 degrees. So we went all the way around once. Well, then I need an angle measure that would be the same line, but within 0 to 360, which means I would want something now in this green one, but instead of it being 400 degrees, it's now 40 degrees. And if I had a negative angle that would be coterminal to that, well then, instead of going counterclockwise to find my angle measure, I could actually go clockwise. So here, if I started here and I went all the way around to here, well, that would be negative 320 degrees, coterminal. So hopefully we understand the 2 parts to that. Here it's saying 900 degrees, negative 900 degrees. So I would take negative 900 degrees, and I'm going to subtract from that any situation where I have 360 degrees. If I take away, or add in this case, if I'm adding 360 degrees because this is already negative, well, if I add 360 degrees, it's going to not get me where I want to be. It's still going to be too big. So I would have to multiply that by the number of times I'd have to go around it. So if we think about this in terms of a picture, negative 900 degrees means 1 revolution is 360, 2 revolutions is 720, and then I'd still have 180 degrees to go. So it would be putting me here. I would need to go backward 2 circles. So 2 times 360 degrees here. And that would give me an answer here of 180 degrees. That would be my positive answer. I could just take away 1 here, or 2 of them, and that gives me my negative 180. Sorry, that's my negative answer, not my positive. Then if I want to find the positive, take negative 180 degrees, and I'm going to add another 360 to get the positive answer of 180. These would be the 2 answers that I would be looking for. Hopefully that made some sense. Let's get on to the next one. So the next one is saying negative 175. Well, within 1 revolution, that really is the answer. But if we were to look for another one, we could say negative 175 degrees. We could add 360 degrees. That would give us a positive answer. And negative 175 minus 360 could give me another one. But remember, this is already within 1 revolution negative. So that one wouldn't really change too much. This is 185 degrees. And the other one would be negative 535 degrees. So here would be my 2 answers. Hopefully we see that. In order to find a coterminal angle with the angle in degrees, we would do the following. We would either add or subtract 360 times k, where k is an integer. We'll talk more about that as we go further along. The next one, find a positive angle less than 1 revolution that is coterminal with the given angle. Well, now we're talking about pi values. We're talking about, in particular, fractions, and that's going to be something you guys got to work on here, is being able to figure these things out. This is saying is 12 pi over 5. Well, 5 into 12 is 2, and then a little bit extra left over, 2 pi over 5. So this would be 2 times around the circle plus another 2 pi fifths. How we're going to do this, it's going to be, sorry, not 2 times around the circle, 1 time around the circle. 2 pi is 1 time. So 12 pi over 5, and we are going to subtract from this one 2 pi. How would we do this? Well, we take 12 pi over 5, and we're going to subtract 10 pi over 5, and that leaves us with an answer of 2 pi over 5. This would be the positive within 1 revolution. Hopefully we understand that one. Let's take a look at the next one. Hopefully as we get going with these, you'll see what we're talking about. This one says 23 pi over 6. And we need to eliminate pi here. We got to get ourselves down within 2 pi. So what are we going to subtract here? Well, if it said 24 pi over 6, hopefully you guys would agree that's 4 pi. 4 pi would be 2 times around the circle. I need to eliminate one of those. Well, it'd be almost, well, that would be. So this is just short of 2 times, 2 complete rotations around the circle. I need to get rid of one of those. Well, if I'm going to have a 6 down here, then I've got to have a 12 pi up here. It's eliminating 2 pi. We are subtracting 2 pi. When we do this, we're going to get 11 pi over 6. And that would be our answer. You're trying to subtract until you get within 2 pi. And remember, 12 pi over 6 would be 2 pi. Let's try the next one. This is negative 9 pi over 4. I need to get all the way around to a positive answer here. So negative 9 pi over 4, instead of subtracting, I have to add. And if I'm over 4, then 2 pi converted to a fraction that's over 4 means 8 pi. And when I do this, I'm going to get negative pi over 4. Are we where we want to be? Well, we are not, because we're still in the negative region here. So it tells me I'm going to have to add another 8 pi over 4, which then gives me an answer of 7 pi over 4, and that is a positive answer that is within 2 pi, 0 to 2 pi. Hopefully we're getting the hang of this. How about this next one? This one looks a little bit different. It's saying 1177 pi over 7. So I need to figure out what I'm going to do here. How are we going to approach this problem? So the first thing that we have to remember, 2 pi in this particular problem is going to be 14 pi over 7. That's 2 pi. And remember, every revolution we have to take something out. If we look back at these problems where we use degrees, we were adding or subtracting 360 degrees, and we just kept doing it till we found the right answer. This one, a little bit different, because when you're using the fractions, you have to remember that even though it's over 7, it takes 2 of those to get all the way around. It's taking 14 pi over 7 to get all the way around. So the way these work, you take 1177, and you're going to divide by the number of times. If you just divided by 7, well, then you're saying you're going halfway around the circle. You got to divide here by 14. If you divide by 14, you're going to get approximately 84.07. Now, when you do this, this is the part that you're interested in right here, the 84. You don't care about the 0.07 here. Okay, this is already bigger than it would be to go 84 times around the circle here. So in order to get this understanding in your head, you got to understand, I don't want to go past that. I want to, if I use 84.07, whatever it is, then it's going to put me at a place I don't want to be. I want to be between 0 and 2 pi here. So I'm going to use this number, 84, and what I'm going to say is the following. I'm going to take 1177 pi over 7, and I'm going to subtract, because I need to go down in this case, this one's positive. I'm going to subtract 14 pi over 7, but I'm going to multiply that by 84. I'm doing that because I need to get past this thing. I got to go beyond. I want to get to a point where I'm doing that. If I take out my calculator, let's just explain it this way. If I take out my calculator and I say 14 times 84, well, that gives me 1176. That means if I'm using this particular method, then 1177 pi minus 1176 pi is going to give me the answer I'm looking for. So I'm going to write it out here. 117 pi minus, or divided by 7, and that should be 2 7s, sorry. 1177 pi over 7. I'm going to subtract 1176 pi over 7, and that's going to leave me with an answer of pi over 7. That would be the coterminal angle that is within 1 revolution, and that's how you find it. So that's one of those things you're kind of just going to have to work on a little bit. These fractional ones are a little tougher, might take a little longer. How about this one? It's a positive value. Because it's positive, I got to subtract something. I'm looking at this thing. I have to subtract 2 pi worth of things. Well, pi is really, in decimal terms, rounded off 6.28. So if I subtract 6.28, that's 1 time around the circle, I'm going to get an answer that says roughly 3.61. Is this within 0 to 2 pi? Well, sure, because 2 times pi is 6.28. This is the answer I'm looking for. It's in decimal equivalents, but it's no different here. So in order to find the coterminal angle, when the angle is in radians, you are going to add or subtract 2 pi times k. And this once again where k is an integer. So go ahead and try this one. Find a positive coterminal angle between 0 and 360 for this many degrees. And then I'll come back and we'll talk about it. Pause the video and try it yourself. Okay, hopefully that makes sense. Take your big number of 114,567, divide by 360 because this is in degrees. You're going to get 318 point something. You don't need the point something. You just need the 318. And then you're going to say it's 114,567 minus 360 times the number of times you'd have to do it, 318 times. That would put you at 87 degrees. That would be the coterminal angle. All right. Find the positive radian measure of an angle that the second hand of a clock moves through the given time. So this one's always kind of cracks me up because we need to kind of talk here about what we mean when we say the second hand of a clock. So you have your clock. I'll just do it this way. Here's our center. You have a long hand. You have a shorter hand. And then you have, I'll change colors here. Normally it's red in our clocks at school. There's a third one running like this. So when we are talking about the positive radian measure of the angle that the second hand moves, of a clock moves, what are they talking about? Well, they're talking about the hand that's measuring seconds. And which one measures seconds? It's this one. It's the second hand. The one that's measuring seconds. This one's measuring minutes. This one measures hours. So when they are saying the second hand of a clock, they're saying this thing. So any given period of time. So 50 seconds. How do we want to approach this? Well, the first thing we want to point out to you guys is that the question is saying that they want you to find the positive radian measure. That means you're going to have to use radians, not degrees here. 50 seconds. Well, how many seconds are in a minute? 60. So that means this is 5/6 of a minute. We're going to multiply that by. Now, when you think about a clock in a minute, how far radian measure did you go if you go 1 minute with the red hand, with that second hand? Well, you go 2 pi all the way around the circle once. So 2 pi, you're going to multiply by 2 pi here, which means we're going to have 2 pi, we have to convert that, so 5/6 times, this is 12/6, and then we're going to multiply that together, keeping in mind that we could simplify this a little bit. We can say here that 6 goes into 12 twice, so this is 10 pi over 6, and then that reduces down to 5 pi over 3. So fractions. If you're not good with fractions, you need to get better at them because you're going to need them for this section. 5 minutes and 30 seconds. Well, 5 minutes, how many pi did we go? If you just went 5, forget the 30 seconds for a minute. If you just went 5 minutes, how many revolutions is that? Well, that is 5 revolutions. So 5 times 2 pi. That gives you 10 pi. And then 30 seconds would be how much in terms of that? Well, it would be another pi. And so total, you would be 11 pi. That's how far you would go. Now, if we did this in fractions, we could do it like this. It's 5 minutes, and half of it, or 30 seconds is 1/2 of a minute, so it's 5.5 minutes. Well, when you convert this, 5 times 2 is 10, plus 1 is 11. 11 over 2, and we're multiplying that by 2 pi. 2's would cancel. and we're left with 11 pi. Two different ways to do this one. One, you're just thinking it through. Two, you got to do a little more work. In this next one, 6 minutes and 24 seconds. Well, 6 minutes means 6 times around this, so 12 pi. 24 seconds, however, is not quite as handy, so we kind of want to think that one through. 24 over 60, we need to reduce this. Looks like 4 would go in, 6 would go in, so all told 12 is going to go into the top one, leaving me with 2, and 12 goes into the bottom one, leaving me with 5. So 2/5 would be this one. And then it's saying you're going to multiply by 2 pi over 5, which is going to give you 4 pi over, not over 5, over 1. That's going to give you 4 pi over 5. And then you're going to have to add to that 6 minutes. Well, 6 minutes was 12 pi. Well, that means then you're going to take 4 pi over 5, and you're going to add 60 pi over 5, and that's going to give you 64 pi over 5. That's usually how these are written. They're not normally written as a mixed number of any sort. You can't say 12 pi and 4 pi plus 5 or over 5. It doesn't work like that. The other way you could do this, just convert it all. This would be 6, and we said it was 2/5. Well, 6 and 2/5 would be 6 times 5 is 30, plus that is 32 pi over 5, because that's what this is, pi. This one was also pi. This one, pi. And then we're going to multiply that by 2 pi over 1. Well, that's 64 pi over 5. Either way works. Sometimes the mixed number is quicker to just convert the whole thing than it is to add later. Your choice, what you want to do here. Okay, I know my notes looked a little bit different. This is actually now should look the same as what you had. So we're going to go ahead and do this problem. 2 connected gears are rotating. The smaller gear has a radius of 4 inches, and the larger gear has a radius of 7 inches. What is the angle in radians through which the larger gear has rotated when the smaller gear has made one complete rotation? So we have to think about this one in terms of the small gear first. It's saying the small gear is making one rotation. So how far is that one traveling? Well, it's traveling an angle measure of 2 pi. So if we start the process by saying S is equal to, this would be R times theta. Well, then R is 4 inches, and theta is going to be 2 pi. So we have an S measure here that's going to be 8 pi in terms of inches. We don't necessarily need that right now. And then, because what they're asking you here is, what is the angle rotation? So we don't necessarily need the lengths here. Once I have the 8 pi, then I have to deal with the big part of this. And basically it's saying that we're going to be looking at having a surface area, same formula here, but now they're saying what's the angle rotation? Well, then theta would equal S divided by R. So that's going to equal the S part of this, which is, oh, I shouldn't have done that. Dang it. Okay, so I noticed that my notes were a little bit different than yours, but this is the continuation of this particular piece. We're going to just kind of follow through here. 2 connected gears are rotating. The smaller gear has a radius of 4 inches, and the larger gear's radius is 7 inches. What is the angle in radians through which the larger gear has rotated when the smaller gear has made one complete rotation? So I know that when I turn this gear, the 4-inch gear, this 7-inch gear is going to be turning in the opposite direction. This thing is saying that it's going through one revolution. So everything's got to be in radians because that's what they said. So the first part here is we need to find the arc length of the smaller one. And the smaller arc length is going to be R times theta. which means 4 times the theta measure, which it said it went through 1 complete rotation, 2 pi. That means that my s in this first one is 8 pi. And then I'm going to take that 8 pi and I'm going to plug it into the other equation, which is dealing with the larger circle. And now I know that the larger circle has a radius of 7 inches. And I also know that I'm looking for the angle measure here. So I'm not looking for the intercepted arc length. I'm looking for the angle measure. And the angle measure would be the arc length divided by the radius, which in this one, the arc length was 8 pi. And we're dividing that by the radius of that second circle, which is 7. And that would be our measure. It's going 8/7 around the bigger one, which means if you figure 7 over 7 is really 1, and that would be pi, then this thing's going 8/7, so it would be somewhere over in here, and it's traveling this far to get there. Or if we're looking at it from an arc length measure, it would be going that far. So hopefully that makes sense. Important formulas that we need to know: coterminal angles, they land in the same position on a circle, same terminal side. 360 degrees plus k, or 2 pi k, where k is just an integer. Now it's saying they want you to fill in the unit circle with the 3 things they're naming here: the degrees, the radians in exact form, and the radians in decimal form. I'm not sure if we're giving you that paper or you're going to fill it in yourself, but either way, make sure you look for it. I'm just going to pause here and make sure you have that. Okay, this last part is saying they want you to practice a little with where these things lie, in which quadrant they would lie in. So if you have your unit circle handy, you should be able to just look and see where these are. I'm just going to draw a quick picture so we get a rough idea of what's happening. And in my picture, I'm going to put some information here. This is 0, this is pi over 2, this is pi, and this is 3 pi over 2. And then this would be 2 pi. And then I'm also going to put in some degree measures. So this would still be 0 degrees, 2 pi, or 360. This one is 90 degrees. This one is 180 degrees. And this would be 270 degrees. And then variations of all these. The last thing I want to put in this little picture, because this is really what they asked you for. So the last thing that I want to put in the picture, hold on a second, I got to get this thing back to the bigger screen. The last thing they want is the decimal equivalents of these. So 2 pi, that's really 6.28. Pi over 2 is really close to 1.57. 3.14 for pi. And then 3 pi over 2 is really 3 times as big as pi over 2. So if I multiply 1.57 by 3, I get 4.71. And now with those things in there, this should be fairly quick to see. Which quadrant does each of these lie in? 2.3. Well, that would be in this quadrant. Oh, making sure we understand this is 1, this is 2, this is 3 here, and this is 4. So 2.3 would put us in the second quadrant. Negative 390 degrees. Well, I'd start here, I go clockwise around 360, and then negative 30 more. That puts me in the fourth quadrant. 5.7, if I start at 0 and go counterclockwise, 5.7 would be before 6.28, but after 4.7, so this is in the fourth quadrant. 7.01, start at the initial side, counterclockwise, 1 complete rotation is going to be 6.28. This is going to be just beyond that, so we are in the first quadrant. Negative 11.34 degrees. I'm going to let you do the last 4. So do the last 4 based on what you see, and then we'll come back and check. Pause the video now. Okay, here were the last parts of this. Hopefully this makes sense, and we will see you in the next video or in class. Have a good one. Bye.